Welcome, ladies and gentlemen, to Warwick Science's film G9 Practicals of the neutralisation reaction. Now, the neutralisation reaction is a reaction between an acid and a base. And the acid that we're going to be using today is our old friend hydrochloric acid, 0.01 molar, and between sodium hydroxide, which is of the same molarity, which is strength. And we're going to be mixing those two together to see what we end up with. There's a write-up that will come up on screen, and if you would like to pause the video and to write that down, then you can commence the video once you've finished. Okay, the first thing that we probably need to do is have a look at what colour indicator there is for acids, for bases, and for neutral solution. So in here I've just placed some water, okay, into that particular test tube. So what we'll do is we'll place some hydrochloric acid in. Now, as usual with these bottles, there's a couple of rules that we tend to have. Always do the bottle up and never grab the bottle by the lid, just in case it has come off. So there's our hydrochloric acid there, and we have our water in that particular one, and here we have our sodium hydroxide. Now, whenever you're using acids or bases, because they're corrosive, it's very important that you put on your safety glasses. Okay, so we can do those there, and there's our sodium hydroxide. So here again is our standard universal indicator, which is a material we use to be able to determine if we have an acid or a base, and here is the universal indicator chart. Okay, so as you can see there, from pH 3 on this one, which is red, down to pH 11, which is a purple color, and the green one there is neutral. So just getting a couple of 1, 2, 3 drops of this, okay, and putting it together, and you can see there that we have it basically red. So that tells us that it is an acid. So again, our universal indicator in our water, and mix that one together, and you can see that we have a green color there, so the green color being a neutral solution. And then finally in our sodium hydroxide, if you can see they're very dark blue purple color, so that tells us that there is a base. So that tells us what color the base is, or the substance is, with universal indicator. Now I'll come right the way over to this side here, and what we're going to do is I'm going to place 5 drops of well, actually not 5 drops, let's go 10 drops of hydrochloric acid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, obviously these dropper bottles here aren't super accurate, and that'll have an effect on our experiment. So what I'll then do is I'll put a drop of universal indicator into there, okay, or a couple of drops, and that just basically tells us, they're just swirling it around a bit, that as with the last activity, we have an acid. Now I'll just clean up that particular workspace there, because it's always important to work with a pretty nice clean workspace. Now, a neutralisation reaction is a reaction between an acid and a base. So it's putting an acid and a base together to end up with 2 specific substances. So now that we've got our acid in there, I'm going to add the equivalent amount of drops. Now, it's important here that both the hydrochloric acid and the sodium hydroxide are the same molarity, okay, because that tells us about strength. So, and then hopefully we can start to observe what happens. Okay, so we'll just go this way so it's a little bit easier to see. So we go 1, 2, 3, 4. Now you can see there that it starts to change color, and how it went green and it's gone to yellow. What that tells us is that it's still an acidic solution. It's a weak. Now we've got up to 4, 5, 6, 7. Give it a bit of a spin. Okay. And you can see there that it has gone past the neutral, it's gone to a base. So because of that, what I need to do is I now need to add some hydrochloric acid. What we're trying to do is we're trying to make this solution in here green. Okay. Now you can see there that the colour's just starting to go a little bit lighter. Okay, let's run out of acid there. And basically this experiment is simply about, okay, and now we compare those two greens together, okay, realizing that of course this one's a little bit more dilute, but you can see there that we've now matched them up. So but basically what I've got in there is I've got an equal amount of hydrochloric acid and an equal amount of sodium hydroxide. Now you'll notice now though it's just got a little bit yellow, so that means that we just need to add a little bit of a base, and this is a pretty tricky prac because you end up needing to do this throughout the prac. So again there, it's gone basic, so what we then need to do is we just need to put a couple of drops of acid in there, okay, and there we go, it's at the green colour from there. So now we have actually neutralised those two solutions, which means we have cancelled those two solutions out. So we have the exact amount of sodium hydroxide and the exact amount of hydrochloric acid. So the question is, of course, well, what have we got in there? And what we've got in there is in fact water. Okay, so we've now got water, because water is a neutral solution. So when we mix an acid and a base, one of the two resultant substances is water. We also make salt. So depending upon the two reactants, so the acid and the base we put together, we'll end up with a different salt, but the generalized reaction is an acid plus a base will give you salt plus water. And we use neutralization if we do have an acid spill. We actually neutralize the acid by adding a base to it, and then that just renders it water and a salt, and that's not dangerous to humans. Once again, if you fill out your practical report and then go and see a teacher to make sure that you've got the correct information, and thanks very much for accessing Warwick Science's film practicals of neutralisation.